All right. Hello, everyone. Welcome back to the stream. This is, I think, the 7th stream that we've done on this channel so far. And for those of you who are new to the stream, we are developing a game engine from scratch using C and Vulkan. And starting at this point in the project, we're doing it all live here on stream, with the exception of some of the kind of boring stuff that doesn't really need to be shown on camera, such as something that I completed earlier today. So one thing that I did was I went through and commented a lot of the code base because I noticed there were several places in the system that just didn't have documentation comments, and I want to keep up on that. And so I've gone through and added a bunch of those, and this is already actually pushed to the repo. So you guys should already have access to this as it stands. So tonight I don't have really too much on the agenda that is super specific. What I'm planning on doing is hitting a couple of sort of random things that I want to tackle tonight. And going from there. I also want to plan out the next couple of things that we are going to be tackling on the stream. And so we're going to do a little bit of that as well. For those of you who, like I said, are new here, definitely feel free to chime in, ask me any questions along the way. This is an interactive stream. So any of you that have questions about the engine or the project that we're working on, or the goals, or where we're going with it, or just why I'm doing something the way that I'm doing it, feel free to go ahead and ask that at any point. Also, go ahead and toss me a follow for notifications as to when the next stream will be live. I usually stream on Wednesdays. That is the schedule right now. And I stream at, usually I start at 9 o'clock at night, but I wanted to go ahead and start a little bit early tonight just to kind of get a little bit of extra time in. I do sometimes also stream on Thursdays, so there's that as well. So anyway, with that all out of the way, I want to go ahead and jump in to some code. So let me start off by getting rid of this. One thing that that I initially kind of used as an example of why we kind of implemented our kvar system was the ability to sort of turn flags on and off. And so I think a decent place to start is to actually implement one of those flags. And what we're going to start with is, if you recall, when we run this, we have this Vsync flag down here, right? And I can just press V on the keyboard and it turns that on and off. And so instead of having a key binding for that, which is kind of not really great, I think it would be much better to be able to set something in the console. So we're going to convert that to be a kvar, and that way we can set it in the console, and we can also key bind to execute a console command on that key binding if we wanted to. And eventually, the idea behind this is we can also use this for triggering different things in the UI. So if we click a button or a checkbox or something like that, we can use that to toggle this flag, and then that will still sort of follow all through the same path of code. So that is what we are at least going to start with tonight. So one of the first things that we actually need to do is we need to add something to our kvar system. So we have the ability to create a value. We have the ability to get it and set it. However, what we really don't have is the ability to sort of be notified as to when one of these things changes. Now, one thing that we don't want to have to do is for an example like this, where we're constantly having to check to see if Vsync is on or not, we will now have to pull for that on every single frame, right? That's going to be slow because these lookups are expensive, and we definitely don't want to be doing that kind of thing every single frame. So what we really should do here is we should toss out some sort of notification as to when this kvar actually gets set. And then if anything is out there listening to it, it can then go ahead and interpret that message. So this means that we'll obviously need to go to event.h and declare a new event. And I'm going to go, let's see. Let's come down here. We have our debugging one here. This is kind of a debug one as well. I suppose we could add it after this, right? And just keep these. Let's go ahead and put it here. So we'll call this event code. Let's call this kvar changed. And we'll set that to 0x17. Okay. And this will be an event fired by the kvar system when a kvar has been updated. And I think for now, what we'll probably do is just fire out an event saying, hey, this value has been updated, but we're not going to include the value for that because depending on what type of kvar it is, that value could change. It could be a different type. It could be a string. It could be a float. It could be an integer. Or, if we decide to add some other type, it could be that other type as well. So basically all this is going to do is say, hey, the value of this thing has changed. You should probably go ahead and get a new copy of that. And I think that's good enough because that's, again, something that's not going to have to be done every single frame. So I think we should be good to make the assumption that that's enough. So we'll go ahead and set that there. Hey, Night Loan. Thanks for the follow. I appreciate it, man. Appreciate the support. So, Dino worked. Yes, Dino did work. I did notice, actually, that it pinged everyone, which is a little bit weird, because I actually had set up a new role that people could subscribe to that it should be pinging instead. So I'm not exactly sure why it pinged everyone, because it was only supposed to actually ping like that particular role. So that's a little bit weird. But nevertheless, I guess it worked. So yeah, I'll have to investigate that. All right. So where were we? So I think what I'll do is I'll go into our kvar system and we'll include core event. And when we go ahead and set the integer, this is our basically our success case, right? And this is one of the reasons I'm saying we don't want to do this, these checks every frame, right? Is because these things are not fast. Yes, we could use a hash table to make this a little bit quicker. But quite honestly, that kind of optimization just doesn't really make sense yet because this is probably going to be changing. So, but anyway, so when we set a integer type, and we've found the actual variable that we want, and we've gone ahead and set that thing, now we're going to do a event context, and I guess we'll just call it context. All right, we'll zero it out, and we'll say context data C, which is an array of up to 16 characters. The problem is if the kvar is over 16 characters long, this is not going to work. So we may actually need to enhance our context a little bit, but for right now, I think I'm just going to use that. I'll use the string copy. I'll use the end copy to be safe. So the destination is going to be the context data C. The source is going to be the name, and the length is going to be 16. And that should give us what we need. And then we can go ahead and event fire, and we'll use the code that we just created, which is the kvar changed. The sender will be, it's actually going to be 0 because it's kind of irrelevant, doesn't matter. And then we'll pass the context. All right. So how many bugs have I created today? I don't know. I probably already created another one, honestly. Most of what I did earlier, sort of off camera, was just documentation comments. So I don't think, well, I suppose I could have created bugs if some of my comments are wrong. Who knows? Yeah, I mean, for every line of code you write, there's definitely the propensity to have bugs. So chances are I've created several. Should be all we need to do here. I suppose we could also pass along the type. Right now I'm not going to worry about it. I am going to put it to do in here. To do also pass type, potentially. And basically, we will listen for this in the same manner that we are listening for sort of the keyboard input. I believe I put this stuff in game, is where the key map was, if I recall correctly. Vsync. So we're using the renderer flag enabled here, and I think we're just changing this manually, if I remember correctly. So let's just do a quick search on this. That's the only, so it's grabbing that flag every time, which that's kind of poopy. We should probably be caching that instead. But regardless, let's see. So we have, here's our configuration. Where did we put? Oh, that's right. I think we moved this to, what was it called? Game commands. Was it? No, game keybinds. That was it. And then in here, I believe we're just manually flipping this flag. So this is the keybind function that we've currently got bound. And all this thing is doing is just flipping this flag. So what I'm actually going to do instead is I am going to cheat a little bit and create a sort of a static method here. Void toggle vsync, right? And I'm going to move this logic here. Call it there, that way the keybind still works for now. And then we'll also tie this to a event fire. So let me just grab this key code again. So in the keybinds, when we set that up, damn on escape callback. Let's see. I think we actually set these things up towards the bottom. Here we go. Set up key maps. I guess in theory, this is probably the wrong place to put this, quite honestly, but I'm going to put it here anyways and create more tech debt for myself later on, because that's the right way. Event register. We want the kvar changed. The listener is, I think that's actually irrelevant in this case. And if I recall correctly, we should just be able to toggle vsync. I think that actually requires a... Yeah, it requires a signature, so I got to change that up a little bit. Let's do another crappy thing, just because... Was that... It is a B8, okay. So let's call this B8 game on kvar changed. And we'll just pipe this through to our actual function, which is this guy. All right, let's go ahead and make this static. And we'll set this here. Okay, so this way we actually have two sort of entry points to the same thing. We can get rid of the key binding in a minute. But let's see. Welp, you're out. Got to do story writing or something. All right. I appreciate you jumping in there, Night Loan. Appreciate the support there. See you around. All right. So toggle Vsync. So we've registered for that. Actually, I think that might be all we need to do, except actually create the kvar itself. So let me have a look real quick. I think we're setting that by default. And the kvar system should be stood up before the renderer, so we should be able to actually create that here before we initialize the back end. So we'll go ahead and create the Vsync kvar. Let me just double check the systems manager and have a look at the order. I'm pretty sure though. Let's see. So we have events, kvars. Yeah, kvars is pretty far up the list. This should say memory, not console. Okay, so yeah, we should be good because kvars are created pretty early and definitely before the renderer. So in the renderer itself, we will need to, I believe, include kvars because I don't think we have those. Yep. Okay. Let's put that here. Core kvar. All right. And we'll go back to this and kvar create int. We're going to call this vsync. Yeah, that should be good enough. And then the value that we're going to do is, what we're actually going to do is check the flags to see if this is actually set. So we'll say this, let's see. So if that flag is set, then we'll say 1, otherwise we'll say 0. All right, we'll just sort of treat that as a Boolean, and that should be sufficient. That way, no matter what we change here, or when I should say, we eventually expose this configuration to the application, we should be good. Okay, so now that we're automatically creating that kvar, when we actually launch the engine, we should see that run. Before I build this, I'm pretty sure I forgot to include kvars in here. And I did. So include core kvar.h. All right, let's build. Oops, missed something. What did we miss? Incompatible function types. Game on kvar changed. What did... oh, right. Derp. Return... I'm going to return false to say not handled on that. That's one of the issues anyway. Still bleating that we have a different... Let's see. B8, U16, void pointer, and then on event. So here's the code. Passing null there. What is... primitive type? So it's complaining about this being the wrong thing, but isn't. Pointer function on event. Oh, wait, this shouldn't be... This should be event context. What am I doing? Copied the wrong thing. And in fact, let me just go here. Yeah, listener instance and then data. Oh, that should be code sender listener instance. Jeez. Calvin, you should have stuck around for a couple minutes longer. I created some bugs, just like you said I would. Wait, that's event register. Here we go. Okay, this is where I need to put it. Okay. Now, obviously, we should not be doing this on every kvar changed, right? So we actually need to do a little bit more processing here. So if the code is equal to kvar changed, right? Obviously, we need that. And the data.c, so we'll do a string equal I. We'll do this against vsync. Right, so if the code is what we expect, as well as the data string itself being set to vsync, then we should go ahead and do the thing. And that should fix it, actually. Okay, so let's go ahead and run. And we'll open up the console, and we will say print all, what is it? Actually, I think it's kvar print all. So there's our vsync 1, right? Let me just move the camera, make that a little easier to see. So there's the kvar print all vsync 1, so that is defaulting to what we expect it to. So now if I say kvar int set, and then we change vsync, and we set that to 0, we should, if I type the command correctly, kvar, was it set int? Vsync 0. There we go. So what this has actually caused is a bunch of things in here, and actually this is kind of what we expect, right? So we flipped the vsync to off. I went ahead and echoed that for us, recreated our swap chain, and then says, resized booting, which technically is not a correct message anymore because that doesn't always only happen on a resize. It can happen on any reason that we need to recreate the swap chain. Changing vsync is one of those reasons. But we see down here, our vsync has flipped to no. So if we go ahead and try flipping that back to 1. Whoops, did I get the wrong? Yeah, it's int set. Right? Int set or set? set int. That seems backwards. Let's go ahead and set that to 1. Then it is flipped back to Vsync. So with that said, actually, I want to look at that because those kvar commands aren't really consistent, are they? So we have, well, I guess maybe they are. They're just not consistent with my code naming scheme, which is, so we have kvar create int, kvar print int. So, okay, I guess we have, I guess that's, yeah, the verb is sort of in the middle. So I guess that's consistent enough. I'm all right with that. All right, so anyway, so we have that flipped over to our new method of doing things. So what we can actually do is, and what I'm actually going to do instead, is I'm going to change our game keybinds a little bit. And instead of our console key map, not the console key map, the input key map for the game, testbed key map. Here we go. So instead of this, using this sort of debug vsync, toggle that just toggles vsync, right? Instead of doing that, what I'm going to do instead is I'm going to say console execute. Oh, you know what? I don't have console in here. So this is kind of an example of how we can use the console within the UI. So I'm going to include core console. Let me actually move that up a line, right? And I could say console execute command. And here I can just say kvar set int. Oops, that should be in a string, right? Space, and just as we would type it into the console, we can say vsync, and then we'll actually need to sort of toggle this, right? I guess. So instead of doing this toggle vsync thing here, we would then either say 1 or 0. So let's see. How do I want to do this? Let's do it this way. Let's say const char command equals this. And then we'll just swap this out, right? So we'll say vsync enabled. So we'll go ahead and get that. And then we will instead, let's see. In fact, actually, yeah, that should be fine. So next, instead of passing this directly, we'll say command here. And we can say command, let's see. Let's get length first, I guess. I'm trying to think about the best way to do this. String length, command, right? And then command length -1 to grab the last character. And then we'll say equals, if vsync is enabled, 1, otherwise 0. Okay? And that should be single quotes because it's the character. And oh, because it's const character. Should just be character array. And then we execute that command, right? So instead of handling it this way, we go ahead and we execute the console command. So whenever we press the keyboard key, it's essentially the same as inputting this into the console. So to prove that, we'll go ahead and build. And we'll run. And we'll come down here and I'll just adjust the view a little bit here. And I'll go ahead and press V. Whoops. Exception. Did I? Length is 20. Why can't I set? Did I miss something here? Something stupid? Kill all these things. Command. That should be what I expect. Why won't it do length minus 1? That should be 19, right? So how's this any different than saying this? Oh, right, because that's a constant anyways. Yeah, I don't think that's going to work because I can't write to that. Yeah, because I need to create a copy of that. That's why. Because I'm a dummy. Because that's constant data and you can't do that. Let's just do this the cheese way. So I'll just say, I don't know, 30. Make sure to always have enough room. And then string copy. We'll use end copy. Command. Really? Okay. Maximum of, we'll say, 29 characters, right? Need that. Right. Now we should be able to do that. It's been a long day. Again, Calvin, you should have stuck around. I'm apparently creating bugs today. All right, now let's run. So we should be good to go. When we hit V, it flips the flag. And if we open up the console, we will actually see, let me just adjust the camera a little bit. So if we adjust the camera here and we open up the console, we see that it automatically called kvar set int vsync 1. So if we close this out, hit that again, open it back up, we see that it called it with vsync 0. So the point here that I'm illustrating is we can actually use something like this to build out a console command and in a very decoupled way toggle things and make events fire and things from the UI where it doesn't have to know or care about what the data is or how it gets there to the end structure, right? We could just say, hey, flip this flag to its opposite value, for example, and we can just forget about it in the UI, right? And then whatever needs to know about that, we'll know about it. So this is a pretty powerful system that we have in here that obviously this is just kind of a rudimentary example of a use of it, but you know, the power of this and flexibility of this is going to be something that we're going to leverage a lot going forward. Okay. So the next thing that we want to go ahead and do is, actually, I'm wondering, should I? Do we have any other things that we can move over within our keybinds? Theoretically, we could get rid of this, but I'll keep it here as an example for you guys in case you want to know how to do that. And of course, when we start creating UI controls, I'll also create an example for that. We also have some of these other debug things. I don't think I'm really going to worry about re-implementing any of those, though. They're all super specific things, so I think we're just going to move on. All right. So let's do a quick git status here. Yeah. All right, so we've got 5 files changed. I think before we move on any further, I'm going to go ahead and just commit this. So let's say git add, git commit. We'll go ahead and call this hooked up Vsync kvar, right? And that'll sort of be the example that we use going forward. For our other kvars as we need to add them, right? All right, let's get rid of this actually. All right, so the next thing that I kind of had in mind that I wanted to do was I wanted to start thinking about our UI system and how we might start building some of that out. And I've been doing a lot of thinking on this in terms of how I want to actually set this up. And there are a bunch of different options out there. So one of the most common things that people tend to do, especially for debugging tools these days, is they will use something called Dear IMGUI. And that is basically what is called an immediate mode GUI, hence IMGUI. And basically what that means is you have state that gets stood up and rendered every single frame. And you don't basically, you essentially execute that line by line. So you'll configure a control, and then you'll create a control, then you'll configure that control, set a whole bunch of properties, set the next control, set a whole bunch of properties, adding an image, a button, a checkbox, etc., etc. You'll do all these things, and then you'll go ahead and render all of those things, and you'll make explicit render calls in line to render all those things. And you'll do that every frame. And that definitely has its strengths, and it also has its weaknesses, right? So that's sort of an immediate mode GUI. And then, you also have what is sometimes called retained mode. And retained mode is, yeah, I guess that's, let me open up Paint, right? Because Paint. And that is way, way too bright. So let's start off with black. Why is this so bright? Do they not have dark mode for this? I guess they don't. Whatever. Doesn't matter. So let me get a thicker line here. We'll go with... I haven't used Paint in ages. Let's go with a 4 pixel line. Right. Why are you not drawing? Okay, you know what? I'm not going to use Paint because I haven't used Paint in a long time. I don't know why I didn't just open Affinity, which is what I always use all the time. Anyway. Wow. What are you doing, Windows? Why did it open Edge? I don't want Edge. I want Affinity. me just create a new document here. Doesn't really matter what size it is. Okay. Should have just used this. Okay, so we'll go ahead and fill this with black, and then we use a white brush. We don't want the selection brush. Here we go. So I've been told that sometimes it helps folks understand stuff if it's a little bit more visual. So I'm going to try and be a little bit more visual in my explanations going forward. So what we have is we have two modes. We have immediate mode, which we'll just badly abbreviate IM, right? And then we'll have retain mode, which we'll call RM, right? And these are our sort of two modes. And basically the difference is for immediate mode, and I'll just use the text here, we basically, white text. So we stand up, set state, and explicitly call some render function every frame. And the advantage to this is that the application itself doesn't really have to care about where all of this state data is held, because there really is no state retained at all. The application just basically says, hey, do all these things every single frame. And because it's reconfigured every single frame, that can make your code a lot simpler to understand, because you know exactly what's happening from top to bottom every single frame, because you can literally follow it line by line and understand what's going on. So you can see where all the set text happens and all that kind of stuff. And so this is great. This is certainly one way to do it. Some frameworks will actually also say you should probably also set up and tear down your buffers, or your vertex and index buffers on every frame, which can be a little bit of a drawback if you can imagine either standing those things up and tearing them down every frame, or simply just reallocating within a large buffer. That all of those things still take a lot of time, right? And so immediate mode has its pluses and its minuses, right? So retained mode, however, works a little bit differently. So retained mode basically stores state within the objects themselves. So that is to say, you don't have to stand up an object every single frame. You don't have to, create a button, create a text box, an image box, whatever. You don't have to stand up a new instance of those things and stand up a new buffer every single frame. All of these things are sort of retained from one frame to the next, hence retained mode, right? And so the state is stored within the objects themselves, typically, and then is maintained across frames. And this, wow, I can't spell maintained apparently. Maintained, there we go. And so each of these systems has its benefits and drawbacks. A drawback to retain mode is that you can have state being set and affected from multiple parts of the application. It's not as linear as what you might expect from an immediate mode, and it can make it a little bit more difficult to understand how the state gets affected as you go. And so, for those of you who asked, we are actually going to be implementing both systems, and they both have different uses. So immediate mode tends to be really, really good for editors, for example. Editors tend to have a sort of very linear flow And so immediate mode is really good for that. And that's one reason that people use Dear IM GUI for their editors, is because it's an immediate mode. It's very quick to stand things up. However, usually within game systems themselves, or the final sort of runtime executable, or the UI within a game itself, will typically be retain mode, because it tends to be the more performant version of that, of the two, at least during runtime. And so your end product, your final game, that's super, super important. You know, in an editor, you could sacrifice a little bit of that, especially on the UI layer, and still be okay. But in the end runtime, you really want to be as stateful and as quick as you have to be, and you want to do the least amount of work every frame as possible. And retain mode is sort of where that happens. And so, like I said, what we're going to be doing is we are going to be developing a couple of different UIs. So we are going to be making an immediate mode UI, and we are going to be making a retained mode UI. With that said, we are not going to be using Dear IM GUI. We are going to be implementing these things from scratch, because this will give us an opportunity to explore a potential way of doing these things, or at least the approach that I'm going to take. And I'll go ahead and say that this is not the only approach that's out there. There are lots of approaches and designs for this, and various design patterns. But if you've watched my videos before, especially as of late, design patterns aren't always what they're cracked up to be, and can sometimes get in the way. So we are going to design to solve the problem that we currently have, and not to design to a design pattern, right? And so with all that said, we are going to be doing both of these things completely from scratch. So our editor will most likely use this, and our games will most likely use this. Now, there's also the possibility that we combine these two, and maybe we wind up with some combination between the two. We'll see where we wind up. So the other way that I want to sort of handle this is these two UIs are going to be implemented vastly differently. And what I mean by that is, especially for immediate mode, since that's what we're going to use to create our sort of editor UI, we're going to wind up with a lot of controls that we're going to need. And actually, the roadmap that we have, let's see. I don't know why this opened up Edge. Windows, you are tripping. Okay, so let me go to the roadmap. So I'll pull this down here so you guys can see it. All right. So we have this whole UI system here, right? We have this this layering UI format, load save UIs, like UI editor, docking, drag and drop support, and then we have all these various controls here. All this stuff, 90% of it, is going to be for the editor. So most of these controls are going to be for an editor. And the reason I bring that up is because our runtime is not going to use most of this stuff for a game that we actually create. Like, if you look at most game UIs, most of them have just a few basic things in here, right? They'll have some sort of image box. Yeah, they might have a panel. They might have a checkbox, buttons, radio buttons, maybe, tabs, maybe. And some of these more advanced topics in here, unless you've got a really complicated game with lots of windowing and stuff like that, we're not always going to need these things. And so the way that I am planning on organizing the UI is we're going to have a couple of different sort of layers to this, right? So I'm actually going to delete these things. So we are going to have a few different layers, okay? So right now we have the engine. You know, I can't write with a mouse apparently. So bear with me here. So we have the engine, right? And it right now contains a little bit of UI code, like our UI text control, right? And then we are also going to have another library that we are going to create, which I'm going to call common UI. Okay? And the reason for this is because we may have situations where we want to share controls between various applications. So this is going to be a library all on its own, right? And so, for example, we may want our if we think about our applications, right? We have the test bed, which is not going anywhere, right? We're going to use that quite a bit. We also have the editor, which we're going to be creating, right? That's going to be a thing of its own. So we'll go ahead and box these guys off, right? These are executables, these two guys here. And so we're obviously going to have our test bed pointing to the engine. The editor is also going to point to the engine. But the test bed is also going to use this common UI because that's how we're going to test a lot of our stuff. But the editor is also going to use common UI, right? But if we then go over to here to the other side, and we start thinking about a potential game project, which I am still in the planning stages, but I do actually have some stuff coming on that sometime soon. The game that we're going to create with the engine is sort of a freestanding thing on its own here. And it will have a library of its own. So we'll call this the game lib, right? And it's sort of its own thing here. So, it's also a DLO, right? Or SO. Why won't you draw? Go away. Here we go. So it is a library of its own. But the game itself probably isn't going to need common UI because it's going to have a very simple interface, right? It's not going to need all these other things that are in here. It's not going to need all this, right? It might only need a subset of those things, if even that, right? More than likely, it's going to have a couple of simple buttons, some text that's on the screen. I don't even know if we're going to have anything clickable in it, right? Like we might not even have mouse interaction. We might just interact with the keyboard and maybe like a PlayStation controller or something like that. And so we don't necessarily need to reference common UI, right? The game is going to reference the game lib, and the game lib is going to reference the engine. But we don't necessarily also need to reference this, right? The game lib can also kind of contain its own, we'll call it game UI, right? And that'll be sort of its own kind of little thing that exists on its own sort of parallel universe, as you will. And this can be a very, very simple thing, right? It doesn't need to have all of this weight that sort of comes with it, right? And so we want to start splitting things up into modules, not in the sense of like C++ modules, but into sort of reusable components or libraries that we can sort of plug in. Which also brings me to another point. So we also have this sort of concept of hot reloading that we've discussed a couple of times. Now, right now, the engine itself is not hot reloadable, right? And for the foreseeable future, that may not change, although I'd really like that to change at some point. But there are a few things that we're going to have to change in order to support that. But one thing that I would like to do is also have a sort of library that sits here that is sort of the testbed hot reloadable library, right? and then an editor hot reloadable library, right? That maybe goes up here and references this, right? And so we are going to be making some architecture changes for that because we do want these things to be hot reloadable. So ultimately, our applications will be testbed, editor, and then game, right? And then our hot reloadable libraries will be this guy, this guy, this guy, and this guy, and probably that guy as well, right? So we want to be able to hot reload all of these things. Now the engine, like I said, at least for right now, is not hot reloadable, but we do want to change that potentially at some point. But in order to do that, we're going to have to get rid of a bunch of static data, which we've already kind of started moving in the direction of, but we're not quite there yet. So where do we go from here? Well, there's a couple of ways that we could do this, right? So we could create all of these things as massive libraries, or we could split things up into tiny libraries. But one thing that I've started thinking about is we also are going to have some other things that we're going to need as well. So depending on platform, depending on what renderer we want to support, depending on what audio library we want to use, depending on what maybe physics library we want to use, we want to have a way to basically plug those things into the engine and say, okay, well, for this game, we want to use, I don't know, PhysX, maybe as our physics library, right? Because we're not going to be probably generating one of those completely from scratch on our own, because that's kind of a long, tedious process on its own. That could take easily 100 episodes on its own. But, so that it might make sense to actually use that there. But, we might also, for a different game, use something a little bit similar, like Box 2D if it's a 2D game. So we want the ability to sort of plug and play these various pieces, right? And the same is actually going to be true for the renderer, right? And the renderer backend is sort of in the engine right now, and we're going to wind up moving that. And so what we're going to wind up doing is, let me delete all of this. So what we're going to wind up doing is we are going to implement something called a plugin architecture, right? And what a plugin is basically you have a central, let me switch back to white. So you have your basic central engine right here, right? And in it, you've got basically all these sockets that you can think of, right? That you literally plug things into. Now, what do I mean by this, right? So maybe this one is the renderer. Maybe this one is for sound. Maybe this one is for physics. Maybe this one is for networking, for example, right? And maybe this one is for a scripting language, right? And you sort of build this architecture in such a way where you have the ability to take all of these different libraries of code that meet a certain interface and sort of plug in to our main engine, right? And then all we have to do is we have our application over here. It references this. It also potentially supplies these plugins, right? Or tells the engine which ones to use in some cases. And we put all those things together, and the engine centrally doesn't know about any of the plugins, but it knows that plugins are a thing, and it knows that there is a sort of generic interface that plugins use to instantiate themselves and integrate themselves, but it doesn't really know much more than that, right? And depending on the plugin type, it can do different various things. So we're going to wind up having a plugin architecture where we can register various different types of plugins that do or perform various different tasks. So we might wind up with a couple of different plugin types. So we might wind up with, I'll put my list over here. So we might have like a renderer plugin. We'd have an audio plugin, right? We'd have a physics plugin. We might have a networking plugin. And then we might have something that is just a generic plugin, which doesn't meet any sort of specific interface that the engine knows about, but extends the engine in some way unknown to the engine. So what do I mean by that? So an example of a renderer plugin might be a Vulkan render. I'm going to have to shrink the font size here. Let's step this down a little bit, but that's enough so that you guys can hopefully still read it. Right, so we have like a Vulkan render plugin, right? Or a Direct 3D render plugin, right? And we can configure in the application to determine which one of these things that we use. And this render plugin would have a very specific interface that would need to be implemented, and more than likely the interface for this would actually be the renderer backend interface. That would just sort of double as the plugin interface in this case, because we already kind of have that. And so that would basically involve us taking all of our Vulkan renderer code and moving it out of the engine into its own library, and then dynamically linking that. And so here for the audio plugin, we might have like fmod audio plugin, or OpenAL audio plugin, right? And those are just a couple of examples. There's also like DirectX audio that we could use for Windows if we wanted to, et cetera, et cetera. There's some pretty decent audio libraries out there. We could also explore some audio stuff on our own, but for reasons I won't go into right now, we probably are not going to be rolling a audio engine from scratch, only because that can be a very tricky thing to do cross-platform, because they're, especially on platforms like Linux, where there's so many audio implementations out there, it can get messy kind of quickly. So physics might be, physics plugin. Wow, did I really spell that wrong? Plugin. Or it might be, bullet physics plugin, etc. Right? But a generic plugin might be something a little bit different. So another thing that a lot of you have asked me about is scripting languages. And scripting languages are something that I do not plan on natively supporting, because we have the architecture that is going to support hot reloading. And that's something that we're going to have to implement very, very soon here. But we could have a C# script plugin, right? That would be an example of a generic plugin, right? So the engine itself would know nothing about that, but the C# script plugin would basically include all the logic for compiling the C# code that's input, executing that bytecode, and making, of course, the calls to the central engine and engine plugins, such as the renderer plugin. It would be responsible for, routing all of those calls. And so that would be one example of how we might actually implement scripting. Now, again, I have no interest in adding a scripting language to Kohi, at least not now, just because we're already going to have kind of scripting in C for free, just by hot reloading. And scripting languages tend to add sort of a lot of technical debt. So I have no interest in adding one of those things right now, but yeah. So that's basically the direction that we're going to go. Okay. And there's a lot that needs to be done to support this. So basically what we're going to do is we are going to take this a chunk at a time, and I probably will start with the renderer plugin first, standing up the plugin architecture and all that. We'll probably start with the renderer plugin first, since we already have kind of a lot of that sort of developed and in place already. And this is basically going to replace our sort of front end, back end thing. It's basically going to be the same concept, but it's just going to be named a little bit differently. I came up with the plugin idea sort of after I started the development of this whole thing, and I kind of like the plugin architecture idea for this. So basically, everything with this engine is going to eventually wind up being some sort of plugin. And that means that if there is a certain aspect that you don't like or need, you could simply remove that plugin or swap it out with one of your own. Okay, so basically what I'm going to do is, since this is a lot of sort of under the hood type work, I am going to be streaming a lot of this development, but I'm going to try and weave it in with adding some new features as well, just so we have some visual updates, right? Because doing everything, all this work without any sort of visual update is going to be kind of hard to follow after a while. And so what we're going to do instead is we're going to tackle a bit of this at a time, and then we'll do a sort of a visual update, as it were. So we have that. We have UI, but I'm also going to start looking into other things like terrain generation, and eventually adding some water, some decent looking water, maybe a dynamic skybox, things like that. And also animation is something that I want to get in sometime soon. And so that is sort of the direction that we are going. One thing I just want to call out real quick, if you guys do have any questions, feel free to jump into chat and ask. I'm always willing to answer those questions. This is interactive, right? So as this grows, as we get more viewers here, I hope that you guys will definitely feel comfortable asking me questions and having conversations as we go. All right, so with all of this, where do we begin? Well, I think probably the best place to start is to start thinking about this architecture. So we have something called a plugin, which for now is basically going to be a unit of code. And that plugin can be either you can basically have a library of code that contains multiple plugins, which is how we're going to set this up. And then if we want in the future, you could also, I guess, have a one-to-one relationship with those, where you have one plugin per DLL/SO, but I think that can get messy kind of quick. So at least for the Vulkan renderer plugin, we are going to be creating a Vulkan renderer library. And so I think that's probably where I'm going to start. So let's see. So we have testbed. I think probably the best place to start, actually. Let me just collapse some of this stuff here, so we can start looking at the actual layout of this. So let's see, bin, let's get rid of that, collapse this. Let's go, here and add a new folder, and we're going to call this Vulkan. Do we want to call this Vulkan renderer? Vulkan renderer? Yeah, Vulkan renderer works. Okay. And then we're basically going to copy one of the library setups that we have. So really, I think engine is actually the only real library that we have. So we're probably going to have to actually copy engine's sort of setup here. So I guess probably the best way to do that is, first off, we'll create a source folder. And then go ahead and create a I'm going to create a Vulkan main.c. And this is basically just to verify that the library works. Okay. And actually, I need to create also a Vulkan main.h. And I'm not going to worry about linking a bunch of stuff yet. I want to just make sure that this is hooked up correctly. So I'm just going to include core engine.h, right? Not engine. Actually, I don't even want to do that. I want defines.h, right? Because we want to do a u32 test get int, right? And copy this. Return 69, right? And of course, we'll have to include the h file as well. So Vulkan main.h, okay? And we have our build all, which we are going to add something to this. So since technically the thing that sets the plugin is going to be determined by the application, this needs to be built after the engine, but before the application. So we're going to put it right after the engine, actually. So I'm going to say makefile engine make. Should we change this to... Should probably change this to library, right? Because the executable... we have assembly here. So we need to set that externally. That's probably what we're going to wind up having to do for engine. So we're actually going to need to change engine a little bit too. Okay. So let's go ahead and comment that out. Needs to be set by the caller. Okay, and we're actually going to rename this to library because it's not just the engine. All right, instead of including engine here, we probably also should include, pretty sure the executable is just using, oh, it is using engine. Let's actually grab this though. So we'll go here. Let's do this, right? Because that will be, essentially engine will get past there. Here's another one. Engine source. Wait, is that using backslashes instead of slashes? I should fix that. Oh, wait a minute. This might need to be that way. Yeah, there's a couple more here. So we've got this. And looks like we have lib engine. Yeah, this should also be assembly. Right, and this should be assembly as well. Right, so that should be all of the instances of engine. Which means that we need something like this. Let's see, so target version major. Let's put assembly right there, and we'll call this engine. And this needs to be changed to library. And I'm actually going to comment that one out for now, because I actually need to get this working first. So assembly equals engine here. And in this case, we do want this stuff. We do want version gen. All right, let's go ahead and try cleaning this and building. Yeah, I didn't think that was going to work so easily. Okay, so object engine. So let's double check what we have actually changed here. So, oh, wait a minute. Yeah, we haven't actually, you know what, let me undo this rename real quick. I'll change this back in a second, but it'll make it a little easier to see the diff if I don't rename it first. So let's change that. Let's put this back. And let's build. Why is it taking so long? Not sure why that was taking so long. Let's try that again. What am I missing? Why is that taking so long? Oh, wait a minute. I was editing the SH, not the bat. Yeah. Derp. I don't know what that's doing, actually. All right, so that should be fine. This needs to be engine make targets. We need to have assembly there. There we go. All right, so in theory, our bin should be, you know what, let me clear everything. All right, so everything's gone but the console log. OBJ is empty. Let's go ahead and rebuild all. Make sure this is right. Okay, so that seems good. Let's go ahead and just run this real quick and make sure it works. Okay, so we're good. All right, so that's the engine. Now, we also are going to need another one of these for the Vulkan renderer lib. We're going to use the same make file, except this time we're going to call it Vulkan renderer. Should we bother with this versioning stuff? I suppose we could. It's a library all the same. Do version. Let me double check, because maybe we really don't need to do the versioning stuff for this. So this literally just only does it if it's equal to yes. So I'm actually just going to hard code that to no. So we don't do that on there. So we're going to do Vulkan renderer, which is also this matches up with this. So we actually should be able to do that right away. However, the only problem with this is going to be is right now, this only looks at the include for the assembly itself. It does not allow you to include other assemblies. How do I want to handle that? So we probably need to have some sort of way to include other assemblies into this script. Whether it's via arguments or what have you. So we might want to do something like, oh, and this is another thing we're actually going to need is what are we linking with, right? So the source files. Yeah, because this probably won't compile because it's not going to be able to find the types, but let's try it anyway. Yeah, I didn't think so. Performing engine. Syntax of the command is incorrect. So the assembly is here. What about the syntax is incorrect? That's kind of strange. I don't see anything that's like immediately wrong here. In fact, I don't even think I need those things at all. Are we even getting OBJs for this? Yeah, we are. So it's at least getting that far. It's just not actually finishing. All right. So what is it missing here then? So I thought we got rid of all the engine references. We did. This is specifically here. Oh, that one might have to be a backslash. Nope. Build Windows debug, terminated. Let's see. Scaffold error 255. Why is it failing on engine C? That is beyond strange. But yet when if I comment this out, I bet it works. Yeah, it does. So what am I missing? what am I missing in the engine make file? Is it something in this batch file that's wrong? Let's see. I don't have any weird spaces or anything. It's literally a copy of this. The only difference is that. I wonder if it doesn't like the underscore for some reason. I can't see that being an issue, but let's try it. Which means I'll have to change this. No, it's not that. Clean. Oops. I don't want to rename the source. I want to rename this guy. So it's billing engine. Creating library. So it created the engine, leaking engine, creating library, an object, XP. So it must be something in here is just wrong. Action is all. That shouldn't have changed. I don't see any obvious issues here. I guess I could... Actually, I don't think Windows wants quotes, I think. Oh, this is going to be the Vulkan renderer. Yeah, so it is getting that far. It's failing here for some reason. In the scaffold phase. So let's have a look at scaffold. Object directory. All this stuff should be created if it's needed. It's any source. What about this? Generate version file. Oh, this might be the problem here. This is probably where the issue is. Because I'm guessing. Yeah, this stuff shouldn't be done unless this is true. That's probably part of the problem. Only part of it, though. If equal, Windows failed. Wait, but why though? So for those of you who are tuning in, I am basically going through the process now of adding a new library. Currently, only our engine library is actually set up to use this makefile. This was pretty tailored to the engine DLL compilation all on its own, and so I'm trying to make it generic so that I can build more than one library. Because basically we have these two makefiles here, one for the engine and one for the executable. And I need to make this more of a library-specific makefile instead of just the engine, right? Because we're actually adding another library. And I'm currently stuck on basically figuring out why this makefile is throwing up. Oh, probably these guys here. Does it not like? I don't find this file specified. Okay. So is this a tab character? Is there actually a tab in here? Or is it spaces? It's tab. Okay. So I feel like this right here is the next thing that's kind of failing. And it should be... I'm thinking it just doesn't like that much nesting. I'm trying to decide what to do about it. Because basically we only want to perform all of this logic here if we're actually doing versioning. Otherwise, there's no sense in doing any of this stuff. This has always been running no matter what, which was kind of a bug anyways, so we do actually need to fix this. Maybe it just does not like being tabbed over so far. That can't be right. I wish it gave me like a line number that it was failing on specifically. But I'm pretty sure this is where it's choking. Linking version gen. Did version gen actually get... Yeah, it got generated, I think. Clear again. Yeah, version gen worked. Why are you being a bananas? All right, I suppose I could take... I know what I'll do. Well... It probably doesn't like all of this stuff happening before this. If I had to guess. I ran into problems with that in the past. I suppose I could just like kill the version generation for now. Version file. Just undo this stuff. This is the thing. Like if I try to run this now, syntax of the command is incorrect. So we're basically generating our engine, but when we go to, in fact, our Vulkan renderer here, when we're going to compile that, our Vulkan renderer compilation is actually failing. It's going to be something stupid. It always is with make files. So I guess let me plug this back in and just see. We shouldn't be doing any versioning stuff here. I don't think that's going to work either. Yeah, it's not. Okay, so I think what I'm going to do is I'm just going to clobber this for now. Okay, there we go. So that was definitely getting in the way. Oops. So we're definitely going to have to come back and revisit that. Defines not found. Okay, so this is actually what I was expecting to happen. So basically what we have here is this is not resolving because we are not linking with the engine. And so I need a way in the makefile to actually determine that. So right now, all we are doing is we are including based on the assembly source, and then we are linking based on the assembly object directory, right? But we need a way to add these in here, right? So how do I want to do that? I guess I could just do additional include directories and additional linker flags, because that'll give me the flexibility to do this as well, which is probably what I want to actually do. So yeah, let's do that. So I'll say additional link flags, and I'll also do additional inc flags. Right. Directories is also going to be directories. So I guess that'll have to also be additional directories. So we'll need this additional include flags. So we'll need that for the Linux version and the Mac version. Right. And then we'll need the additional link flags. So that'll be here and here. All right. And directories. Directories should actually just be the defines. Okay, so those are the only two things I actually should have to add. So that should be fine. All right, so here for the Vulkan renderer lib, I'm going to set this equal to And I guess I will actually do engine source. Actually, that needs to be a backslash for Windows, right? Yeah. Not sure. I might need a trailing backslash there. I'm not 100% sure. And then additional link flags we can also do. Additional link flags equals how do I want to do this? Because that's object. That's the object directory, right? So I guess I could just hard code it for now. Yeah, we'll say obj engine source. Yeah. And that should, I think that should give us what we need. Let's go ahead and build. Okay. Linker input unused. That's interesting. Linker input unused. Oh, right, because derp. This actually has to be the full flag. So this needs to be -I and -L. And then we also need lib engine. Or I think it's L lib engine. Oh, is it just engine? Do I need engine.lib? Cannot open file engine.lib. That should be, that's going to be bin, right? Am I using the bin? Let me double check that. So object directory assembly. Object directory is just obj. That should be fine. Build directory. Okay. Well, that looks fine. Additional link flags. That should be what I need. Object directory assembly. Object engine. Maybe it just needs to be oh wait. This should be, I think that's supposed to be the min. It's been a while since I've set one of these up now and looked at it, so yeah, it is the build directory. It should be bin. Pretty sure. Yeah. L build directory. Okay, this one I can actually, yeah, okay, so actually this additional link flags, this does not need to be here. Yeah, I was gonna say that didn't make any sense to me. Actually, yes. Wait. No, I shouldn't have to do that. It should just be that and then add that. Right, so that for Windows. That for Linux, and same thing is going to be true for Mac. Right? Yes, there we go. Okay, cool. All right, so now, basically all we need to do to get these things to compile is the additional include flags just needs to include the additional include directories. So in this case, engine. And then the additional link flags just has to include lengine because all that stuff gets built here, right? So we can see here that we actually have the Vulkan renderer DLL here. So we are generating that correctly. So now in the executable, so the executable is actually going to need similar flags, actually, because the executable right now is, I think, just using hard-coded engine. Yep. So we've got it hard-coded in here, in a lot of places, which is not great. So we actually need to switch this to be more dynamic as well. So instead of this should really be an additional link flag. And then we can actually get rid of this hack because we could just not specify that for version gen. Yeah, that makes a lot of sense. So that's what we're going to do. Okay. So we have this, which I'm going to go into the executable and append. So we have, oh, this already has the build directory on it, right? So that's actually, we can get rid of that. So we just need the additional linker flags there. That's for the Windows version. I'll go ahead and put, instead of engine link, I'm going to put additional linker flags there. Instead of engine link here, I'm going to put that here. Additional linker flags there. And then instead of that include there, it's going to be additional include flags. So in fact, I'm going to move this to the end so that we include our source first. So we've got that for the OS X version. We'll do the same thing for here. And then the same thing for here. Because Windows requires the lib, so this whole engine link thing can actually go away. Linker flags, object directory, engine. Okay, so that's going to go away because we have additional linker flags here. This engine business, I think these are the only, so engine, so we're going to get rid of that, rid of this actually. Get rid of this engine link stuff here. I don't even think we need to do that anymore either. All right, and then we can come back to the build all and come down here. Oops, that's the SH. Okay, so the executable not make, we have the assembly already. I'm just going to copy pasta these real quick. Additional include flags and link flags. So we should actually just be able to do this. These right now, the test bed and the tests only use the engine right now. The tools also only uses the engine. So I think that is, this version gen, I don't think version gen actually references anything. No, just uses standard libraries. So we don't need anything to be linked there. So let's do a clean. If you guys have any questions in chat, feel free to jump in and ask. Let's do a build. Okay. It looks like everything linked properly. Let me just go ahead and run. Yep. Okay. So we are actually running. Okay. Let me also test this with running a task, and we'll do a post build. So post build also works. So it's pretty safe to say that this is working as intended. Okay. So the next thing that we want to do is, so our Vulkan renderer is going to be a plugin, right? So we're going to need a way to tell the engine, hey, this is the plugin that we want to load, and here's that plugin. Or hey, this is a library we want to load, and here's that library. The engine is not going to know anything about that. So ultimately, I'm thinking what we're going to have to do is probably load up the plugin from the perspective of the application and tell the engine about it from the perspective of the application. Which means that the application will know what plugins we're loading, the engine won't. And that actually makes a lot of sense when you think about it, because the engine knows that the plugins are a thing, it knows about the interface, but it doesn't know jack about what those plugins actually contain or what they're doing. It just knows that they exist. So, yeah, the best way to pull this off is going to be for the application to know about it, because the application is what is going to be fully aware of what it's using. So, in this case, basically the test bed is going to have to stand up the Vulkan renderer plugin. So it is going to link with that, and then it will go ahead and register the plugin with the engine once we have that in. So what I'm going to do is reference, for now, the plugin, or the library rather, with the test bed. So here we already have the engine that's being referenced. This is, I wonder if spaces are going to screw this up. I have a feeling it's probably going to. So let's do Vulkan renderer and Vulkan renderer, right? And that should give us the linking that we need. I think I'm going to have to maybe wrap some of this in quotes. Which is going to be, that's going to be interesting. Yeah, so I think this is going to poop itself. Maybe not. Maybe not. I'm going to echo that because I'm not... Maybe it is... Yeah, I'm not 100% convinced it's going to actually get all of that. Yeah, I'm going to echo that out real quick. So let's go to executable. and where we have our additional include flags. Let's do down here after we're setting all these variables and stuff. Let's do an echo for that, and it was linker flags, right? Not link flags. It is link flags. Okay, thought so. All right, and let's just see what this is actually getting. Missing separator. Oh, all right. Maybe I'll just cram this in here. Oh, right. Echo is off. Echo. Engine. Testbed. Here we go. Okay. Yeah. It is only feeding me the first thing. So let me come back here to, let's see, testbed. Yeah. So it's only feeding this part in. The space is actually screwing it up. So I'm going to try putting quotes in here and see if that actually fixes it. Nope. Let's see why. Where is testbed? Yeah, so it is including all this stuff now. Cannot open file. Well, why the heck not? So it's added this here. But where are the... Oh, L bin. There it is right there. Can't find the lib. Engine.lib is definitely right there. Vulkan renderer.lib. Oh. Why is that not generating... Why is that not generating a lib? Why are you not generating a lib? You definitely should be. Additional flags is here. That should definitely be generating a lib. Let me do a clean and a rebuild. Still no lib. So what was that I had in here? about Windows being dumb and requiring a lib. I think it was up here. Engine link. We added a .lib. Object directory. Engine link. So that is literally just slamming on a .lib. Okay, so is it really just as simple as where is it? But why is that? But that's bizarre because oh, I know what it is. I know what it is. Because we're not actually exporting anything, you dingus. This needs a KPI. So we're not actually exporting anything. It's not going to generate a lib. I forgot about that. That's a gotcha if I've ever seen one. All right. Yes, that is what it is. So anytime you're creating a library specifically with MSVC as your backend, which is what we're using here on Windows, that is very much a thing. Where if you're not doing a decal spec DLL export, at least on one thing, no lib gets generated. So that's kind of a nasty way to find out. But now that we have done that, we do have a lib file here, which is exactly what we want. So now that we have this, I'm going to come into testbed and let's do entry.c. And I'm going to test this actually right here in our create application. So to do remove temp. Okay. And I'm going to include it right here. And I'm going to do what was the name of that? Vulkan main.h, which incidentally we're going to have to adjust our IntelliSense, I think, to pick that up, because I don't think that's going to work out of the box. So we basically just need to call this. And I'm going to do it right here. Right? So we'll say u32 test num equals this, just to make sure it works. And if test num, so we don't get a not used error. And let's build that. And what do you know? It compiles. So we'll go ahead and run this. And we see here that we got 69 back. So we do know that it is all linked up and hooked up. And now our build system is actually a lot more dynamic than what we had before, where we can just kind of feed in our configuration within the batch file. I'll have to update the shell file here in a second. But now we can just kind of feed in some configuration within that build script that we have, and it will sort of just set this step up for us, and it'll just work. So we have that. One more thing we have to fix is this issue, because we don't have configuration to actually deal with this. So that is going to wind up being in our CPP properties. And that is just because we have to add an include path here. And that is just going to be Vulkan renderer. Right, we do that, we come back here. We might have to reload the window. But now we should have IntelliSense there. Or not. Define the function to create it. Why is it? Did that not work? It is Vulkan renderer, right? Vulkan underscore renderer source. Oh, that's under Linux, you dingus. Linux, Mac, Win32. Now it should work. All right, so I can F12 to that, and I can get that. So comments, right? Documentation comments should work. Yay. So with that, we have everything that we need hooked up to start moving code. So we have our new library set up. Our makefile has now been adjusted to be much more dynamic than it was before, so that is all well and good. And I think it's actually linking with everything we need. There are a couple more things in here, though. Vulkan is always being linked with every library, which is dumb. So let me actually see. Yeah, there's a bunch of Vulkan stuff in here. This should really be under additional include flags, which is actually going to get tricky because of this bit. Which is actually, believe it or not required on Mac OS X. So that's going to be a little bit more tricky. But we don't really need to... We really don't need to be linking everything with Vulkan, so we should probably fix that. How do we want to handle that? Well, I think before we do that, let's take the batch file changes and move those over to the shell file. So I'm actually just going to do split to the right, and we'll make the changes here. So in fact, since I'm going to be changing this, the makefile actually needs to be renamed as well. So let's do that as well. Instead of engine, go ahead and change this back to library. This needs to be library. This needs to be library. And then, where was that? The sh file. So this is going to be library. This is going to be library. Let's undo that. So the first thing is, we'll just go by these one by one. So we have an executable for our version gem, which I don't think requires any changes. The engine is next. You know what? I should probably put some comments in here real quick. So this is the engine. This is the Vulkan renderer lib. This is the test bed, I believe. Target. Where's the assembly on this guy? Wait a minute, what? What is... Am I missing something, or is the assembly just not here? What is this? Right? Assembly. What is this even doing? Oh, right. This is the new one that we just... Oh, what a dingus. Nope, it's not. That is doing absolutely nothing. So that's neat. We've just been like building nothing, I guess. I wonder if that's where some of that entry point error stuff has been coming from, actually, that I've seen before. I wonder if that's where that's coming from. Anyway, this is going to be tests and tools and yeah, okay. So all we'll need to do here, let me just move this back. So the engine doesn't really look like it needs anything. Are we not doing the versioning in this either? Really? Okay. Oh wait, that's version gen. Oh. Oh, I see what happened. Okay, I need to... Wait, no. I'm confusing myself here. Let me... Okay, so we have tools, tests, testbed, Vulkan renderer lib, engine. But this is version gen. So did I... Right. I hadn't actually created a new entry for this yet. This is the engine. This is the version generator. Okay, now that makes a lot of sense. All right. So the assembly is engine. Major and minor. Do version. Okay, so engine is unchanged from that, other than it needs to be library, which we've done. Okay. The Vulkan renderer library is using the library.make. Its assembly is Vulkan underscore renderer. Same thing with the versioning. The version here is going to be no. And then we are going to copy these flags. Let's see. So this needs to be created or converted to a /, but I think otherwise that's fine. So that's the additional include flags and the additional link flags. So that should be good to go. Testbed is now going to use these additional flags, which I'm going to have to test this on Linux and Mac to make sure that doesn't break horribly. So that may wind up being a small update I have to apply off screen, just FYI. So when you guys actually, if you guys aren't viewing this live, just note that that might have to be fixed off stream because I can't reboot in the middle of the streaming. Okay, so here we have our additional include flags and our additional link flags again. And in fact, I'm just going to copy this. So we just need to apply this for that tools. And we should be good to go on that. All right. So we have all of that set up. Oh, I think I stuck some echoes in here somewhere. Yeah, let me get rid of these. Don't need those anymore. Okay. The only other thing that we're doing is I don't think the executable uses Vulkan anywhere, nor should it. Okay, so that's fine. We do, however, in the library, always link with Vulkan, which is wrong. So realistically, the only time that we need to actually do this is for the Vulkan plugin. So this will be an easy change for Windows, right? Because we can just slam this into additional link flags and additional include flags. So let me actually do the include flags first. So executable, build all that bad. Here we go. So the engine. Right, the engine doesn't need it. It's this guy that needs it. So here's the additional include flags. This has got multiples in it, so we're going to have to wrap this in quotes now, which you probably should have just do anyways, just to be safe. Okay, so there's the additional include flags, and then the additional linker flags are going to be these two guys. And I don't know how this is going to work with this environment variable here. Right, because we need to do that. And I don't know if this is going to expand automatically. I get the feeling it's probably not. Right, so we have that, the additional link flags. Okay, so we're just going to fix the Windows version for now. The Linux version and the OS X version we're going to do separately. But I think those are the only 4 instances of Vulkan in here. So let's go ahead and build this. Yeah, that's what I thought. Unresolved externals everywhere, meaning it could not figure out the path. So, in the batch file, oh, I wonder if I can just do, this like that, because I think that's what batch files actually require. That might actually be what it needs. Nope. See, can we actually see the linking engine? Oh, right, the engine actually does need it right for right now. Right. Because all that stuff actually still exists in the engine for right now. So this does actually need it for right now. Output file name matches input file name. Oh, right. Because it doesn't need either of those things, right? It doesn't need that, it doesn't need that. It only needs the Vulkan includes. Right. Okay. So, ram to do, remove Vulkan from additional linker include flags, right? Because really the Vulkan render lib should be the only thing that does that. So let's do a clean rebuild, because I want to make sure that this stuff works on a clean build. And I'm also going to have to translate this over to the SH version. All right, so we've built, let's see if we run. Should be good to go, but. All right, well, that still works. I can move on from that. Okay, so we are good to go here. All right. So that is that. I think I got all the... No, I need to take the Vulkan stuff out of here too for these guys. So what I'll have to do is go to the batch file, all the way here to the end, and grab this. Whoops. So that is for the engine. So let me go here to the bash script, and we'll go here and tack that on to the end. And I think it'll be just $sign in this case, and it should work. Should work just like that, I believe. And then we'll go here to the renderer lib and go here and add all this stuff onto the renderer lib, which I'm actually just going to replace this, right? Oh, these need to be forward slashes. Make sure of that. Forward slash. So this one does need the engine and the Vulkan SDK, which needs to be a $sign. And then this needs to be Vulkan SDK, $sign, / lib. This part may fail on Mac OS X. So I may have to do some detection up here. Some OS detection, perhaps, to see if we are on Mac. Because I don't know if that's going to break it. So I will have to test that, obviously, off camera as well. But that pretty much concludes us adding our new library. Now, next time we go to add new library, it's not going to be anywhere near this involved. Because we had to go through the steps to actually make these things more generic. And so now that we've made those things more generic, we won't have to do that next time around. It should be just more configurable from this perspective. So we should be good to go. And I'm going to start wrapping up here. If you guys have any questions, go ahead and pop them now. I'm going to, let's see, get status. Just make sure that there's nothing in here that I don't want included. I don't think there is, though. So we've got our configuration changes. Yeah, we should be good to go. I'll leave that example code in entry.c for right now until we get ready to actually bootstrap that the right way. So get checkout. And I'm going to do a new branch. I'm going to call this feature plugins. Do I want to say plugins? Yeah, I'm going to call it plugins. So I'll add, and I'm going to say created new Vulkan renderer lib made build scripts more flexible. That's pretty much everything we did. And then I'll go ahead and push origin feature plugins. Now, I'm doing this as a feature branch because I don't want the main branch being broken while I investigate this. And I'm technically going to keep this feature branch open until we have at least moved the Vulkan renderer into this new library. And then once that migration is complete, I will probably open up a pull request and go ahead and merge that in. I think I've already gone over pull requests on the stream. If I haven't, if you guys are watching this on the YouTube archive or something, leave me a comment about that, and I can go over it again. But yeah, we have the feature plugins branch here. So if you want to see this code, that's where that's going to be. All right. Yeah, and I think that is actually where we're going to wrap up for tonight. So it's actually end of the stream time. So that is going to do it for tonight. Thank you guys so much for tuning in. For those of you who showed up, I really appreciate the support here. And, if you guys haven't already, give me a follow. Check out my YouTube channel. That's where all these live streams are going to be archived going forward. And, with that, I'm going to go ahead and shut off the stream now. So thank you guys again so much for joining. This has been actually more productive than I was thinking it would be tonight. So, yeah. Anyways, I'll see you guys later.